Welcome back. In this video, we're gonna try to answer the following question. We are given this function, f of x is x over the square root of 1 plus x, and we wanna see if this function is surjective. Remember that we have, in general, a function defined from some set I into some set J, and we say that f is surjective if every element here get hit by some element from the set I. Okay, or we can prove that as we see here, that the image of I is J. So that means we every element here has a pre-image, or all the elements here get hit by some element of I that we call X. Okay, so here we can show this result here by showing that the image of the I of this function, that means the domain of definition, and the range here, okay, is the whole subset or whole set of real numbers. So here the domain is we have to have 1 plus x bigger than 0. That means x bigger than -1, and therefore the domain here, or we're gonna use just I, is -1 plus infinity. Okay, so this is the domain for our function. So to prove that f is surjective, and we're gonna prove that our function has the following: f of I is just R. Okay, so J in this case is R. Okay, because here there is no problem for every x. We're gonna see that from this top x, this one is gonna be positive, but this one will take all the values between -infinity and +infinity, and therefore the range is R. Okay, so here we can say that our f now is defined from I onto R, such for each x it does associate a x over the square root of 1 plus x. Okay, so to prove that f is surjective, we need to show that the image of I is just R. Okay, so to do that, we see that here in I we have a problem in -1 and +infinity, and we see that f is an increasing function. Okay, to show that, we can use derivatives, or we can just use the fact that if x is less or equal than y, then we have f of x less or equal than f of y. Very easy way. Or if you don't want to use this one, we compute the derivative and we prove that's increasing. Okay, so here we use the derivative and we show that f is increasing, but it's clear that f is increasing. Okay, otherwise we have to use the derivative. So, but here f is increasing. We can prove this one easily from here, or the derivative, and we have the domain, and we need to show that the image of the domain is the whole set R. So f is continuous on I, it's increasing, therefore the image of I will be the limit. Okay, because it's increasing. Okay, so it's gonna be something like this, or maybe because of this is -1, so it's gonna be here. So it's gonna be but f of 0 is gonna be 0, so it's gonna be something like this. Okay, so not this one, something like this. So the image of I, so this is the interval I, it's gonna be the whole set of real numbers, and therefore it's gonna be the limit as x goes to -1 from the right of f of x, and the limit as x goes to +infinity. So this is the image. Okay, so because x will take all this value. When x changes in I, its image will be in this range. Okay, in this range, and we see that the limit here, the limit of f of x as x goes to -1 from the right is the limit of x over the square root of 1 plus x as x goes to -1 from the right. So here we're gonna have a small positive, small negative values over big or small positive values. When we flip them, we're gonna get something big but negative. So therefore we have minus infinity, and the limit as x goes to plus infinity, so it's the limit of x over the square root of 1 plus x as x goes to plus infinity. Here, since x is big, we can write x as the square root of x squared. Okay, and we can write the limit as x goes to plus infinity of x squared over x plus 1. And therefore here we have two polynomials, so the limit that wins it's x squared over x, which is x, and we know that x goes to plus infinity as x goes to infinity, and using that the square root is continuous function, we have plus infinity. Okay, so this means that f of I, so f of I is minus infinity plus infinity. That means it's the whole set R, and this means that f is surjective. Okay, so this is a quick way of or a different way of proving that f is surjective. We use a lot of heavy algebra, but nicely and in a algebraic manner, we prove that f is surjective. Therefore, the question is answered. Is f surjective? Yes. And we have proved it. Thank you very much.